Welcome back to another Rise Up, Don't Run math video. In this video, we're going to go over how to simplify radicals. Before we talk about a radical, let's first review what is an exponent, because those two things are going to be related. So an exponent, it also referred to as a power, is a way that we express repeated multiplication. So for instance, on 4, this is read as 4 squared, or 4 to the power of 2, it's telling us to multiply 4 2 times because that's what our power is, which would give us 16. If I wrote 4 to the third power, that would be saying to multiply 4 3 times. So a root, or a radical, is a function that we use to think about how do we go in reverse. So for instance, if I gave you the number 16 and I asked you what is the square root, this symbol here is read as the square root of 16, I'm asking you what number times itself would give us 16, which would be 4. If I gave you radical 36, I'm saying what number times itself gives us 36, or square root 36, which is 6. So before we go ahead and start simplifying radicals, let's next talk about why might we want to simplify radicals. So there's kind of two reasons for this. The first reason comes down to writing our answer in the same format. So we simplify things so that our answers are written in the same format. However, another reason that was the more important reason is prior to having calculators and computers that could do quick computations for us, sometimes people needed to be able to estimate what a square root was. And as the numbers got bigger, it's sometimes harder to estimate if it's not simplified. I'll show you what that looks like in the examples below. All right, let's go ahead now and take a look at 3 examples of simplifying square roots. So once again, we're going to come back to what are our perfect squares. I'm going to go ahead and write these across the bottom so that we have them to look back at as we do each problem. So perfect squares are the number that you get when you square a number. So for instance, 1 squared would equal 1. 2 squared equals 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And we could keep going if we wanted to. The perfect squares here are the numbers that we get once we square each number. So when we squared 1, our perfect square was 1. Our perfect square is 4, 9, 16, 25, and 36. These are called perfect squares because they come from squaring nice integer values. So when we look at a square root, the first thing we want to ask ourselves is that number underneath the square root a perfect square? So for our first example here, we have 9 underneath our square root. Since 9 is 3 squared, it is a perfect square. We can think about rewriting this as the square root of 3 times 3. Since there are 2 3's underneath, or 3 squared, the square root and the squared will cancel, which tells us that the square root of 9 is 3. If you recognize this right away, it's also perfectly fine to go from the first step to 3. Now let's take a look at what if the number underneath our square root is not a perfect square. So for instance, in our middle example here, 32 is underneath our square root, and it is not a perfect square. It's going to be somewhere between 5 and 6 because 32 is between 25 and 36. So the next thing that we want to think about doing is, could I write 32 as the multiplication of 2 numbers, with one of those numbers being a perfect square? So we want to think about multiplying two numbers together to get 32, with one of those numbers being a perfect square. So 1, 4, 9, 16, 25, 36, and so on. Now 1 isn't actually very helpful because right now this could be written as 32 times 1, and it's still not nice for us to be able to take the square root of it. So we want to start with 4. Is there a number that when we multiply it by 4, we get 32? The answer to that is yes. 4 times 8 gives us 32. Since these two numbers are being multiplied, we're able to break apart our square root. This has to do with the fact that square roots and exponents are actually just functions of multiplication. So we have the square root of 4 times the square root of 8. We previously saw that when we have a square root of a perfect square, we can take the square root of that number. The square root of 4 is the same as the square root of 2 squared, which would just be 2, times the square root of 8. Now, before we think we're done, we should always ask ourselves, could the number underneath our square root simplify further? So does one of our perfect squares multiply to give us 8? Once again, we can actually go ahead and simplify this further. 8 can be written as the perfect square 4 times 2. We go ahead and repeat our process by breaking apart our square roots. The square root of 4 is 2, and the square root of 2 is an irrational number, so we leave it underneath our square root. Our final step is to multiply the two numbers that are in front of our square root, which is 4 square root of 2. Now our square root has been simplified. Now, there is a way to avoid having to do this process twice. Let's go back from the beginning and see how we can avoid having to do extra steps. So going back to our process from the beginning, we want to start by asking ourselves again, are there two numbers, one of which is a perfect square, that could multiply to give us 32? We already saw that 4 times 8 worked. However, are there any numbers that are bigger that could give us 32? 9 won't work. However, 16 times 2 does give us 32. So there was a bigger perfect square that fit underneath our square root. Now I can go ahead and split my square roots apart. Square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2 is going to be an irrational number. So 4 square root of 2 is our final answer. Note that we got to the same simplified value as when we did the two-step process. Let's talk really quick about how people used to use this to do estimation before there were calculators. So when we have a square root, we're trying to think about what number times itself would give us 32. What we can think of is thinking about this as 4 times whatever the square root of 2 is. Well, the square root of 1 is 1, and the square root of 2 is 4. So the square root of 1, let me kind of write this out here. Square root of 1 would equal 1. Square root of 4 equals 2. So the square root of 2 is going to be somewhere between the value of 1 and 2. It actually ends up being about 1.4. So if people needed to estimate this value, they could say this is going to be 4 times about 1.4 something, which will end up giving us something that is close to 5.6. Prior to calculators, working with smaller numbers enabled mathematicians to do estimation quickly and more easily. Let's take a look at one more example. For our next example, we have the square root of 38. Once again, we want to begin by asking ourselves, are there two numbers, one of which is one of our perfect squares down here, that could multiply to give us 38? If we check by doing 38 divided by 4, we get 9.5. We want to have nice whole numbers, so 4 would not work. We could check 16, that doesn't work. 25, that doesn't work. So in this case, there are no perfect squares that nicely multiply to give me 38. In that case, what we end up saying is does not simplify. And that is how we simplify square roots. So in summary, there are basically 3 types of situations you can have happen. The first situation is it is a perfect square, in which case you get a nice integer as your simplified answer. If it's not a perfect square, sometimes you'll be able to simplify it, in which case part of it will still remain underneath the square root, and then other times it may not simplify. I hope this video has been helpful, and thanks for tuning in.